All right, so here's the last slide that we have covered last time we saw each other. Just as a recap, this has to do with the site work subtopic of the whole thing. Roughing tools and equipment structures, pathways and raceways. That was the subtopic that we covered last time we saw each other. So cable installation begins with establishing the pathways. All right, so just a recap. Yes, when it comes to installations, things are done in a structured way, of course. So one of these, roughing in. But part of the roughing in would be establishing a pathway. Okay, and what do they write here? Main runs should be kept in bundles and suspended independently of any ceiling structures. Right? So if you have a long hallway, and here is the main communication room where everything home runs to, and there's a hallway, and at the end of the hallway there are some offices. Okay, so you're not going to run one cable from here to that office and one cable from here to that office. One cable. No, you're going to get the whole bundle, so you can get one common raceway. Could it be a cable tray? Could it be J hooks or whatnot? And you're going to pull a bunch of cables from that spot into the spot where things are fanning out to the offices. Okay, so so that's what it means, that that the main runs should be kept in bundles, suspended independently of the ceiling structures. What this gives us, first of all, let's just talk about the main bundle, kept in one bundle. First of all, it makes the cable pulling efficient, and when so we are talking about installing systems not in your home that you have all kind of times in the world that you can install these things and nobody's rushing you. So whenever it's done, it's your private thing. This is we're talking about doing things professionally for a client and on a regular basis, and in a way that you can actually earn a living by doing this, right? So efficiency and professionalism come in play big time when it comes to this. So when you establish a one main bundle, then it makes the cable pulling efficient because you just have one straight line to pull with. Now, when it comes to straight line, so there's no turns. Every time you have a turn, when you pull cables, you have to pull the cables to that point and pull just some extra wire there, extra cables. So it's called pulling a slack. And then you go and do another pull from the other side to kind of get this thing going. Because if you have obstacles like turns and stuff, then you won't be able to pull the cable. It's just going to be too much friction, and you're going to apply too much force, and you actually can damage the cables if you can pull them at all. Right? So straight lines are important. How do you establish a straight line? You get a string or a rope or a twine, okay, and try to establish that one string run. So you tie the string to one end, and then establish a straight path. What do I mean by that? Is when you pop the ceiling tile and you get into the ceiling, it's not just made for us, for cables. All kinds of other things are being installed. Heat pumps, communication equipment, plumbing, and all kinds of, sometimes the ceiling is quite busy there, right? So, so at some point, you're going to see, there will be situations that you're going to have nice and easy access, and there's going to be not too many obstacles there. But sometimes you're going to get into a situation that you're going to have to look for some straight paths. And when you establish that straight run, you tie a string on one end, make it snag and tie it on one end, and this is going to be a reference guide for mounting the raceway. If it's J hooks, that works great, because you just tie install the J hooks right to that, where along that line. Okay, and then you have a nice and straight line, right? And then you can use that string to pull the wires, and you can tie the back string to it, and so you can pull this another string with those wires. So you have the string there, so you can pull more wires there, right? So So now let's see if it makes more sense. Main runs should be kept in bundles and suspended independently of any ceiling structures. And of course, as a recap, why do we have to have that independently of any ceiling structures? Well, because it's the way it has to be done. Good enough? Well, maybe not, all right? A lot of that stuff has to do with, believe it or not, fire rules and regulations, fire code. When the cables are tied to the, well, a common thing years ago used to be tying the cables to the wires that are holding the ceiling tiles grid. So here is the floor, here is the ceiling, which is ceiling tiles supported on the grid, and then above that, there's a ceiling space and there's a true ceiling. Right? So between the ceiling tiles and the true ceiling, sometimes you get 6 inches, sometimes you get a foot, sometimes you get 2 feet, sometimes you get 20 feet up of a ceiling space. It just depends on the building. All right. So that ceiling tiles, when you put the ceiling tiles, the grid, right, metal grid, is suspended on metal wires, right? So it used to be that people, you would just, and you're still going to see that done from years ago, in some cases, that the wires will be tied to those wires that are holding the ceiling structure. Well, that poses a danger. If something happens, let's say there's a fire and there's fire crews that have to come over and do some tearing down. They have those hooks on the sticks and they're going to pull those things down. Anything that's tied to it is going to pose more danger to them. So that's why this kind of rule was established. Plus, years ago, wiring was not as heavily done in buildings as it is now. Right? So things have to be done. And also what happens if somebody releases the building or the floor of a high-rise, business high-rise, they have to remove their wires with them. All right. So there's also money to be made in just removing wires, just like in installation. Right? Okay, so as much as possible, establish straight runs. So pulling. Okay, so I just touched the mouse the wrong way. So we have done that. J-hooks mounted on the walls or suspended from the ceiling or threaded rods. Okay, let's see that. J-hooks mounted on the walls or suspended from the ceiling on threaded rods are the most common in this scenario. Yes, they are. Sometimes you're going to have to install cable tray, but J-hooks are quite often very popular thing to do. Now, so as far as free air and raceways, free air, well, mounting cables on the J-hooks is considered to be free air because those cables are not covered from it, they're just resting on the J-hooks. Now, cable trays, just a cable tray is just like a ladder, kind of extended horizontally in the ceiling space. It looks like a tray. Right? Then yes, it's a cable tray, but it's a raceway, but it's not covered raceway. So all those wires that are there also are considered to be free air, but a little bit more in a more organized way. Right? Raceways as the alternative to the free air method, closed raceways or cable trays are used. There could be cable trays that are closed as well. All raceways should be installed before the cables are run, right? So, well, all the thing I have to say about this one is that sometimes it takes a long time to establish the pathways and installing the infrastructure for the infrastructure wiring. So in some bigger projects, it might take a week to establish just the raceways, all right, or hanging all the J-hooks, or mounting all the trays, or sometimes combination of both, depending on situation. Sometimes it takes a month to establish just the raceways, right? So when you're quoting on the job later on, we'll be working and pricing out the project. You're going to have to include work that needs to be done just doing that, right? And then I have a hint here. Position the J hooks no further than 4 feet apart, and quite often you're going to actually have that specified in the contract. Okay, so the reason for that is if you have a ceiling structure and then you have the J hooks mounted on the ceiling structure. All right, and of course there's going to be a bunch of wires pulled and resting on those J hooks. Right? Wires resting on the J hooks. Now, if you have those 4 feet apart is the sort of arbitrary or by trial and error and then established length between the J hooks. If you have them longer than 4 feet apart, you're going to, under their own weight, cables are going to start sagging like that. Okay, so if there's a bigger bundle here, there's going to be cables are going to be put under more stress than they need to be right at that point. All right. So the worst they're going to it's going to be the worst for the cables that are on the bottom of the bundle, because not only they're going to be exposed to the stress of that point, holding that point, all the sag here, but they're also going to be pressed from the other cables that are on top of it, and it's just like stepping on a cable. And stepping on a cable or altering the physical structure of data cable is bad, because by doing that, you are going to void the specifications of the cable. And all of a sudden, Cat 6A is not going to work as Cat 6A. It's going to behave like a Cat 5E. Right? And when it comes to certifying, that run might not certify as Cat 6A. Right? Okay, let me just erase this thing here so we don't have any obstructions, because I care about you. I care about you so much, and I care about you having the opportunity to seeing my pretty face without any obstructions. There you go. See how caring I am? All right, so let's keep going with the next slide that we're supposed to have here. Press some buttons. All right, so we're talking about mounting the J hooks or cable trays or any sort of raceways, or as a matter of fact, any other ceiling structures or structures, period. Right? Threaded rods. I got some definition from somewhere here. What is that? It's a relatively long rod that is threaded on both ends. It has a thread, so you can install a bolt onto it. It's going like a bolt or a screw or machine screw. Right? So the thread might extend along the complete length of the rod. And this, the bottom one here, description, is pretty much most common thing when you see when you get the threaded rods, because if you go to some hardware store, local hardware store, and look at some of the threaded rods area, if you can't find them, just ask them if they have it, and they'll point you to the section. Just take a look at those threaded rods. You're going to see them of those rods with different lengths and different diameter. Okay, and the beauty of that is that you can cut them to length, to any length that you want, and you have a nice long bolt that you can do something with. Right? So here's an example of how they could be used. It's mounting an air duct using a Unistrat also, and there you go. Then there's some other example of using a threaded rod to support some whatever ceiling structure that is. Very versatile thing. Sometimes it's a lifesaver when it comes to performing installations. So here is the threaded rods. Now, next thing I'm going to point to you is, I'm just giving you food for thought, and of course, you're not going to be a professional threaded rod installer after this presentation here, but at least you're going to have some sort of basis based on which, some sort of grounds based on which you can expand and do further research, and actually seeing, you're going to know what's available when it comes to doing some installations. You're not in the, you're not going to have to try reinvent the wheel when it comes to methodology of installations. All right, so another thing I'm going to point to you is the Strat channel. And Unistrat is probably the most common when it comes to stuff that we would do on the construction sites. That's the strat channel looks like this. And the best description of what I could do is for you just in just a short description would be, well, it's the Lego blocks for grown-ups. When you were kids, you were playing with the Lego blocks, doing all kinds of toy things. Well, you were practicing for doing this, right? So this is the bigger Lego version for adults. Okay, so let's see here. That's what it looks like. And they come in different versions. Like, for example, this is just without any punctured holes or any openings. This would be a solid channel. If you need to mount it on something, you could drill the holes by yourself, or for whatever reason you want to use. It's just a solid channel here. Punctured channel, it has holes in there, and the half slotted channel, it has got some shorter slots along the way, and slotted channel, it's got longer slots along the way. You can use those to mount things onto the ceiling, or to mount things onto other things using things like, for example, threaded rods. All right, and they also come in different sizes. This is a half channel, so it's not as deep, and they're also available is like extended channels. So actually it's maybe twice or three times deep as the regular one. Okay. Definition of a strat channel is a standardized form structural system used in construction and electrical industries. Well, it's just what we described here. For light structural support, often supporting wiring, plumbing, or mechanical components such as air conditioning or ventilation systems. And this is a spring nut mount, which is quite popular when utilizing the Unistrat. Now take a look at, oh, no. See, what happens is that, okay. Again, zoom in. I just have to make sure that I don't click on that, because I made it a link. So you can click on this and you can watch a little video that has to do with mounting the spring nuts onto it. Right? So what do we have? It's a spring nut. It's a nut that has a rectangular base, and it has a thread right inside, into which thread you can, well, mount a bolt of appropriate size. Or you know what? Hey, you can mount a threaded rod in there too, and you can build on that as well. And there's a spring there, so when you install that into that Unistrat channel, the spring makes it stick to it by pressure, so it doesn't fly all over the place. Okay? That's a very common practice, a common procedure when it comes to using. And there are all other kinds of paraphernalia. Just go nuts and research things on your own. And sometimes you're going to you're going to be taught by experience when you get yourself hired, and you're going to see other people using that. And that's how you also learn, by experience, right? J-hooks. J-hooks can be mounted on threaded rods, right? What do we have here? Here's a threaded rod mounted on a steel beam in the structural ceiling. Here's the true ceiling. Oh, look at that. It's a perforated steel. There's a concrete on top of that, and it's covered with on the bottom side with the perforated steel. It's a nice structure, but it just it makes you spend a little bit more time if you have to mount things into it. But you have some steel beam construction, so why not? Here's a threaded rod extending all the way. And then what do we have here? We have a bunch of J-hooks mounted. Here's a 4-inch J-hook, 3-inch J-hook, 2-inch, and 1-inch. And there's 1, there's 2, now you can also mount them both ways, on both sides. You can have on the other side another J-hook here, another J-hook here, and you get the idea, right? So a very, very efficient way of running wires. J-hooks also are specified when you go to some electrical distributor stores. That are very popular stores to sell to get the J-hooks from. And with the specs or the specification sheets on specific J-hooks, it will tell you it will support so many Cat5e wires, or it will support so many Cat6a wires, or it will support so many coaxial RG6 cables, and things like that, right? So you gotta, when you're designing a project, make sure you get the right amount of J-hooks, and you're going to also have to make sure that you specify the right sizes of the J-hooks. Of course, the bigger ones are more expensive, and the smaller ones are be less expensive. So if you have a main bundle, try to get the bigger J-hooks so you can fit as much wire as you can possibly fit there without overfeeding that J-hook, because also if you get too much of a bundle, then if you add to the bundle, cables are are being exposed to a stress of basically the bottom ones are going to have to hold the weight of the top, everything that's on top of them, right? So just just have to consider that kind of stuff. All right, so like for example, if you have the main bundles, you might use the 4-inch J hooks for the main bundle. But if you have to spend, you're fanning things out, so maybe you're going to just have 1 or 2 wires from that main bundle going this way to those 2 offices, then maybe you might want to get a 2-inch or 1-inch J hooks. So so that's as far as project planning goes. And here we have an example of a J hook mounted on the wall, right? The J hooks come, they're not just one kind of, they come in different shapes. Well, they're shape of a J, right? But when it comes to the way they're mounted on things, they might vary slightly depending on the purpose and the needs of your installation, right? They also come in the plastic version, right? And they also have different sizes of plastic version J hooks, and they also have different mounts. These are just a regular J hook, so different sizes. And this is an example of how the wires are being run using the J hooks. Okay, plastic J hooks. Right, enough of the J hooks. See, you're going to have the word J hook ringing in your ears for the rest of the day. All right. So that's why the next slide is more about J hooks. Now, why did I put this slide here? Is it's going to bring us towards the next few slides. Is the way mounting things in a concrete ceiling. All right. So here's an example of a threaded rod mounted not on a steel beam but in a concrete slab ceiling. So a lot of ceilings are going to be hard concrete. One thing I'm going to point out, and I know I mentioned that last term, but I'm going to mention that again. You have to be aware of certain dangers that weigh on you when you're performing your construction duties. One of the biggest things and most common things is something that's called MMMF, triple MF. And it stands for man-made mineral fiber. It's a type of insulation it's a spray-on insulation. So it's being sprayed in the wet kind of a stage, and then dries out and sticks to the ceiling and stays there. And so the purpose of that is insulation. The MMMF fibers are pretty much just as dangerous as the asbestos fibers, because they get into you and they don't come out, and they can cause cancer. So you have to make sure that the insulation that's there, it's not MMMF. If it is it, then there are different procedures that apply to installing that or messing with that period. Right, you have to have full PPE. It's just if you were messing with asbestos. It looks like a dried sewage kind of a pulp sprayed onto the ceiling. It's gray. It's a gray pulp dried out. Aside from that MMMF, there are other types of insulation that look just like it. And you can't tell if you chip away a little bit, and if you just look at that, you won't be able to tell if this is an MMMF or is it not MMF, maybe some other type of insulation. The only way you can tell is that if you send it to a lab and it's analyzed in the lab under whatever microscopes they have and the equipment, and they will be able to tell, yeah, this is MMF or not. But usually the building custodians, they should have the documentation on what's in the ceiling, right? And you need to make sure that the paperwork is shown to you that this insulation is not an MMF and signed by whoever, and it's official documentation, right? It's a common thing to do. So if you're not sure, just to be on the safe side, stay away from that. But now we're going to talk about the concrete ceiling that doesn't have that. I just wanted to mention that to you, right? So the threaded rods and other structural devices can be mounted onto a slab ceilings. Right? What do we do? So we're going to talk about, spend a couple minutes talking about anchors or anchoring or mountings. All right. Change the slide. All right. So here's a threaded rod hanger. First type of an anchor. Let's just take a quick look at that. It mounts onto a ceiling like this. And every anchor, every specialized anchoring systems, you're going to familiarize yourself with the documentation that goes along that. So there's going to be a specific anchor that you will use. There's going to be a model number of that anchor manufacturer. Sometimes you're going to see a website that is associated with that. And quite often you're going to see instructional YouTube videos or otherwise platform videos on how to handle this specific type of device. All right. So with this one here, you would just drill a hole using a concrete bit, right, with a hammer drill, and then you would drive that into the concrete ceiling, and that's enough to support the structures that you need to support. And of course, with the specifications or data sheets of that specific anchor, you're going to have to find out what weight it is rated for, depending on the structure it's driven into, right? Because if what good is it if you can support 500 kilos if the ceiling structure, if you're driving into, is not able to? It's maybe some kind of a softer material, right? So there's different things to consider. Now remember I was talking about the perforated steel ceiling. So there's the pure concrete slab ceiling, and this is a ceiling that is covered with the perforated steel. I'm not sure if you can see it or not, but when you download it, you'll be able to see here's that steel. Now, the procedure of drilling that anchor into here is going to be a little bit more complicated, because first you have to puncture through that steel, all right? So first you're going to have to use regular steel bit and not a hammer drill, because if you use that, you're just going to dull it up in 3 seconds. I mean, the drill bit, and you're not going to have much effect of your work. First you're going to have to drill through that, and then you're going to change the bits, and you're going to use concrete bit with the hammer drill a hole, and then you're going to drive this thing into it. Here's the anchor, right? Or whatever the spec sheets call for and the procedures according to whatever the anchoring system that you're going to use, right? All right, so here's one example. Another example would be, I'm showing you some common devices and procedures. This is a drop-in anchor, right? Drop-in anchor. And what I've done here is, well, of course, here's a reference on where I got this from, so you can expand your knowledge by clicking on this link here, and there's going to be more information about this particular subject. And I also have made a link here, so click to watch. So anywhere you click on that, you're going to see some sort of, well, of course, more information about this particular subject. All right, the drop-in anchors, they are driven into concrete. They're specified for holding larger loads. They can hold a lot of load, providing that the material you're driving that thing into is also strong enough, right? So also it depends on everything, right? Things depend on everything. What happens? So you can see there's a bit of a slit here driven. It's a cut. So you drill appropriate size of hole that the specific one calls for. Of course, this would be driving drilling the hole with the hammer drill. And sometimes it's going to be a heavier hammer drill, because if you have to drill a lot of them, that may be a ½ inch or maybe bigger anchors, if you just use a regular hammer drill, you are going to get tired pretty quickly. All right, so sometimes you're going to have to either buy some of the heavier hammer drills, or you can rent them as well. Hilti gun is one of the example for that. So you drill the hole that is of a specific size and specific depth, all right? And then what do you do? Then there is a specific driver or puncture device that you insert and you hammer that in. So what happens is that when you hammer that in, this thing here expands and just being held in the ceiling. And then whatever you're driving into, it just reinforces the expansion there, and there you go. Here's something that's called a drop-in anchor. Quite popular thing to do. Quite often when you have to do a bigger project, so if you do 2 or 3 of them, that's okay. You can just get by with the regular hammer drill. But if you have to do this thing for a whole day, because that's all you do today, establishing the pathways for the cabling, then it's a good idea to either buy or rent heavier equipment. Hilti gun is an example of it, and you can get attachments to it. So it's a quick lock and load. So the drill bit has a die to it. So you just snap and turn, whatever you have to do, and you just drill the hole, and then you just undo that and just lock and load another the attachment. So instead of having the driver and hammering it in, you just quick snap on the other attachment and go zzz, and that thing does it for you instead of hammering. So it's one of those things. Now when you don't be shy, go to some distributors. Sometimes when it's not busy, go and talk to them. Go and talk to some of the electrical supply stores, and some equipment rental places. Well, make sure it's not busy, right? So ask them some questions. Tell them that, there's no shame to being new in the business, because you know what? Every single one of us at one point was new to the business. So there is no shame to asking questions. Actually, it's going to make you look good. And you might know, who knows, maybe you can pick up a few contacts just out of that conversation, right? So that's the drop-in anchor. All right. Now, also, what's a popular thing? It's a chemical bond mounting, so chemical anchors. Let's just quickly read what I was able to find on the internet as far as definition. Chemical anchors refer to bonding used between metallic elements and the substrate materials. What's a substrate material? It's a material that the glue or the chemical works on, right? So you're mounting a bolt onto concrete. So the concrete would be the substrate material that the metal bolt is going to be bonded with the concrete through the means of the chemical substance that's there, right? All right, so again, it's really chemical anchors refer to bonding between metallic elements and substrate materials. The metallic elements, in this case include rods, like threaded rods, right? While the substrate materials can be a brick or mortar. Synthetic resin adhesives are used to form the bond. They are highly effective when used in high load applications. Sometimes that's the only thing that is going to work. In the previous video, this is the repeat of Monday's or yesterday's video, sorry. I had a situation that there was a bunch of brackets that was supposed to be mounted in the building to hang a bunch of the old-fashioned TVs. So this was a few years ago, right? And the company who was doing that, they used some drop-in anchors, but they used it on the cinder blocks. Then the cinder blocks were not sturdy enough to hold those drop-in anchors. They would work, they were just not holding them as they should have been, right? So I was supposed to hang those TVs, and well, it was my responsibility to make sure that whatever I hang, because I would be the last one who touches that site. So if something happened to someone, I would have to go through a lot of court sessions. Hopefully nobody would die of it. So I just had that in mind, and I just made sure that the structure is sturdy as it should have been, and it wasn't. So I did not hang those TVs there. I called the company who installed that. They came in and they installed those brackets again, and it was just something like about 200 brackets or so. Okay, so it was not a small job. They had to come in on their own time and pull all those brackets out and do different types of anchors. And then I came in again and I go, you know what, these new anchors, that's nice, but they still don't work. So they have to come in third time. But then they did some research and they decided to use those chemical anchors, and they worked. It was nice and sturdy, heavy load. So sometimes it's the go-to solution when it comes to that. Now, when it comes to using those chemical bonds, anything involves anything that involves chemical substances, you have to research the PPE. Make sure that you get the proper personal protective equipment that you need. Some of the chemicals are so toxic to us humans that even touching them is going to cause you some damage, because some of the chemicals are going to get into your bloodstream through the skin just because you touched it. So sometimes you're going to have to wear latex gloves when dealing with that, mixing things, all right? There could be some fumes involved and whatnot. Always research the PPE, that especially when chemistry is involved. Okay. So for cinder blocks, that's for heavier loads when you're hanging speakers or maybe some closures, racks or things like that. You gotta make sure that you use the right stuff. And if you're not sure, you're still not sure, go and visit some fastener places. So all those anchors, screws, nuts, and bolts, they classify as fasteners. Right? So just around the corner from our college, there's FACA fasteners. Right? Go and ask them. Make sure it's not a busy time. See if they can recommend some, because, well, sometimes you're going to have a situation that, yes, I have a job to perform. I have something so-and-so to hang, and it's going to be on cinder blocks. It's going to be on the regular brick, clay brick. Or it's going to be in a concrete. They are those guys who sell that stuff. They know about that stuff. So they will be able to recommend the proper equipment for you to use. And you never know, you might learn a thing or two, and you may have some of your favorite anchors to use in the future, right? Other fastener places would be Fastenal. That's a very popular one. I'm just mentioning some names of it. I'm not associated with any of those. I'm just, from my memory, I'm just quoting that. And or you could just Google Fastenal or fasteners, and whatever city you are in, and you'll be able to find some shops, stores, companies that sell them. And they not only sell those, they specialize in selling these, and they do have people in there on staff that know what is good for what, right? So this was the chemical bond anchors. I just want you to know that something like that exists. Now, when it comes to chemical anchors, the installation takes a little bit longer, because first you just you install the anchor and you don't use it right away. You leave and you come back the next day. You have to give the chemicals a chance to set properly, and sometimes takes 24 hours. All right. From that, we're going to move on to something also that is popular, that is going to be used, and that you're going to use a lot and be dealing a lot with, is the equipment racks, right? Especially the standard of the equipment racks, the industry standard, the most popular, and sometimes that's the only one you can get, and good because everything is made for it as well. So all the equipment is standardized towards the 19-inch rack. All right, so we're going to take a look at that. A 19, oh, I touched the mouse. There you go. Whoa. There you go. 19-inch rack is a standardized frame or enclosure for mounting multiple electronic equipment modules. Well, self-explanatory. Each module has a front panel that is 19 inches wide. It will be the front panel of this particular one. There are different ones, but they are standardized to a certain size. Okay, the 19-inch dimension includes the edges of the ears that protrude from each side of the equipment, allowing the module to be fastened to the rack frame with screws or bolts. Rack ears. All right, so here is what do they mean by the ears. Let's say this is some sort of piece of equipment, and last time I used the example of an audio amplifier, so let's use the same thing here today. So here's an audio amplifier with a couple of knobs here, maybe some indicator lights and whatnot. All right, and let's just draw this in a way that it would look like. Here's an audio amplifier. Right? And quite often you're going to have rubber feet on the bottom, and sometimes you're going to have to remove that if you're going to put a bunch of them in the rack, right? Because racks have certain standards when it comes to the units. So audio amplifiers, quite often they have two rack units. So it'll be the size of one unit, half, and so it will cover two rack units. We'll talk about that in a second. So basically, that's how the audio amplifier comes. I'm talking about the commercial use audio amplifiers, for example, right? And you're going to notice that there are a couple of kind of screws here that who knows what they are doing, and that's well on the other side here. Right? And sometimes you're going to see those L-shaped sort of brackets included in the package, right? So those L-shaped brackets, they're called rack ears. Sometimes you want them, sometimes you don't want them, depending on how you're going to mount this whole thing. If you're mounting this thing in the rack, then you're going to have to attach those rack ears. And the rack ears, they look like this. You unscrew those little screws here, and sometimes you're going to have to use the screws that are supplied with the brackets. You're going to be having two of those, and they just mount like this, and they extend. If I can draw it like this, right? And this would be here the rack mounting bolts. And on the other side, you're going to have as well the rack ears that are going to be extended like that with mounting screws. So those brackets here, they're called rack ears, and the purpose of those rack ears is so you can mount the equipment inside the equipment rack. They just don't stand on top of each other. They're using those rails that you mount those bolts here. Sometimes they're called rack screws. Okay. Should be called rack bolts, or machine screws, but rack screws is a common popular name for that. All right. So okay, after all this spiel that I gave it to you, let's just take one more look at this whole thing, see if it makes more sense. A 19-inch rack is a standardized frame or enclosure for mounting multiple electronic equipment. Each module has a front panel of 19 inches wide. The 19 inches dimension includes the edges of the ears. So the 19 inches would be from here, the end of the ear, to the end of the ear. That would be the 19 inches. here, okay? All right, common use, computer servers, telecommunications console, all the equipment that's made for the rack mountable, they would be the, sometimes you're going to see a little tiny modem that is, maybe 8 inches long. And they're going to be rack ears included, and those rack ears are going to be longer than the modem itself, right? Or some kind of a smaller device. So, yeah. All right, so let's switch the slides here. Racks. Remember the Forrest Gump movie when Forrest's friend was listing the ways to make shrimp? Then there will be a similar list of what kind of racks we have. But basically, we have the wall-mounted racks and floor-mounted or floor racks. Okay? The wall-mounted racks mount on the wall. The floor racks, they stand on the on the floor. All right? And they have different shapes by different manufacturers, but they all follow the standard of the equipment that is mountable on the racks. Sometimes you can just buy the rails and make your own rack. Take a look at some of the labs that we have, B1007, 1009, and actually ours, 1006. There are just the rack rails on each side of the equipment. So you mount a rail to the rack ears of certain power supply or whatever oscilloscope that is there that came with the rack ears. And then there's going to be another thing, maybe there's going to be a rack shelf that also has rack ears. And then once you start bolting this here and bolting that, you just have two rails that are holding the whole thing and making self-sufficient structure. So you made the rack without the rack. Okay, so just take a look at that. I'm pretty sure you walked a million times by that and you didn't see it that way. So walk by that one more time and see if you can put this in the perspective of what I just gave you right now. All right. Okay, so there are different racks, so you can research them. Now, as far as rails. Okay, so we're talking about here this drawing here. There are rack units. So the standards are vertically and they're horizontally. All right. So vertically, the one rack space, so it's going to have U's. One U is a one rack space. All right. Two U's is two rack spaces. Right? So the 1U, what does it here is 1.25 inches or so. No, actually, the 1U space is, what does it say here? 1.752 inches, right? So it's sort of 1.75 inches, 1¾ of an inch. And then it's slightly bigger because you have to have some play when you're inserting equipment. You're not going to have a watertight spaces there, right? So it's like a roughly 1.75 inches plus a tiny bit, so you can have a tolerance to mount things properly. All right. So that's a 1U space, right? So some equipment, some pieces of equipment, they're going to have 2U spaces. Some of the bigger equipment are going to have 3U. So now you know what the U's are, okay? And of course, we talked about the horizontal spacing already, okay? When it comes to the rails, sometimes you're going to have pre-threaded holes. So you can, right away, you can mount the rack screws or the machine screws in there. Right? And sometimes you're going to have those openings into which you can, okay, so here's the pre-drilled, so here's the front of the rack, so you can mount those rack screws, so you can screw right in. And they also come with, often they come with the plastic washers, so when you tie the equipment, when you mount the equipment, and you're going to have to put some pressure on that, so the plastic washer is going to relieve a little bit of a harshness from that metal on metal thing. So for aesthetic purposes, and sometimes they come with the openings, so it's almost like an unloaded patch panel, but it's a rail. All right, it's a rack rail. Then for this, you're going to use the clips, or what are they called? Clip nuts, or nut clips. All right, so here's the nut with the thread in there, and it's mounted on a clip, and you clip the clip to the rail, and you only use those openings that you're going to use. So those racks, you're going to have this rack shipped to you with those rails. You're going to have to look for the bag of those clips, and whenever you go on site, make sure you have that with you as well. And those clips and the rack screws are standard, and they are going to fit those pre-threaded holes, right? So if you go to an electrical store or hardware, specific hardware, if you ask for rack screws, they're going to ship you, they're going to give you those. Then if you use the clips, then sometimes they're going to accommodate these, and sometimes they're going to be slightly different, but they're going to come with their own bolts, but usually they will be accommodating that. All right, so all those bolts, nuts, and screws, and all kinds of stuff, it's the whole science of fasteners, right? I strongly encourage you to do your own research on the fasteners. When you get to the job sites, you're going to ask questions of people who work already, what procedures they use, or you can just visit the fastener places, make sure they're not busy, talk to them. All right, so I'm going, and because when it comes to mounting things, one screw is not equal to another screw. There will be differences, and there will be specifications, how much weight it can hold. Can it be installed inside or outside? Is it corrosive? Is it there's so much stuff that you need to know before you mount some sort of a commercial equipment in a commercial space in a way that it's not going to be hanging just for 3 weeks and then it falls down on somebody's head. You have to be conscious of that big time. So I'm going to leave this here open-ended because this is the last slide. So learn, research, whatever you need to do. There's there's about 30 years of experience that I have doing this in this field, and I try to kind of condense that into sort of synopsis like package. So I give you the ideas that you can expand on. All right, at least you know what they are talking about when somebody is talking to you about installing things in this kind of field. All right. So this is the last slide of the last lecture for this school year. All right, the next week is going to be testing, and we still are finishing up some labs over the next the rest of this week and the next week, and make sure that you have all those labs submitted to the electronic submission boxes that we have set up for you. Right, all those boxes are open, and I haven't closed them. So if you have a lab that you're supposed to submit 5 weeks ago and you haven't done, that box is still open. So just upload it right there. Yes, you're going to get late marks, but it's so much better than no marks at all. All right, so thank you very much for all these 14 weeks for this term and the 14 weeks for the last term. You guys are a wonderful bunch, and I enjoyed working with you. And don't be a stranger if you have any kind of questions when it comes to doing this type of job. Sometimes you're going to get yourself hired and you're going to come up to a challenge. You will need some advice. Don't be shy. Just send me an email. I will help you with whatever I can based on the time that I have. All right. So thank you and have a wonderful life. Is that the thing to say? All right. I hate goodbyes. It's not a goodbye. Thank you very much, guys. And I will see you when I see you, as I always say. Bye.